So we've heard about the political threats. We know something about the recovery of species. Now, Ryan's going to introduce new threats that maybe we haven't even thought of yet. And Ryan comes from Southampton. He's a South African by birth, but he's postdoced in France, in California, and is now an associate professor at Southampton. And he's building strong links with BAS, which I think is great. So there are now a number of different projects which are involving Southampton. So BAS is looking more broadly. And that's inevitably the way that collaboration goes nowadays. Thanks, Ryan.
Easy as that. Thank you very much for the invitation to be here. It's a great pleasure, but it's also intimidating. You know, people my age talk a lot about imposter syndrome, but I'm really feeling it now. There are people here who have been doing this for decades, much longer than I have, and are infinitely more qualified to speak to this, but I've been tasked with wrapping things up. So Phil, maybe not new threats, no, and even not threats. I think I'll talk about pressures, because not everything is necessarily a threat, but most of these things will certainly place pressure on ecosystems. So as Phil said, I'm South African by birth, and that means I cut my teeth at Marion Island in the southern Indian Ocean, where I spent 2 winters. But then finally in 2022, I did manage to set foot ashore at South Georgia, which was really a very special experience for me, because I think it's one of the jewels of the subantarctic or peri-Antarctic. So it was a very special experience, an incredible place. So today I'll speak about various environmental change drivers, as Stephen Chown and Cassandra Brooks call them here. So they've compiled a handy list of those, overexploitation and a few other things. And what I'll do in the talk actually is to go through a few of these. It's really a pick and mix, basically what I felt like talking about. And the interesting thing is I've been playing graph or time series bingo through the couple of days. So you'll see a lot of data and graphs and time series here, which have appeared in previous talks. And thank you to those speakers for explaining those concepts very well. So of these two, the first one, biological invasions and disease, Ash introduced very nicely bird flu, so I won't speak about that, just to note that it is genuinely a threat to a lot of these systems. And then also about pollution, so I won't speak much further than that, but I will note from the MISO summary for policymakers. So MISO is the Marine Ecological Assessment for the Southern Ocean, so a very useful synthesis of a lot of Southern Ocean ecosystem science. And they have an excellent summary for policymakers. They do comment that globally generated pollutants, including microplastics, are increasingly detected in the environment and in the biota of the Southern Ocean, and that has local effects. Sorry, is this mic doing that? Sorry about the sound. I think it's as I move. Anyway, it has, so pollution does have local effects. But getting on to exploitation. So we've heard a lot about the various forms of exploitation or exploitation of various taxonomic groups. And so the interesting thing is, you know, we sometimes think about the Southern Ocean, Antarctica as relatively pristine, and that is true when we compare it to other ocean ecosystems, perhaps. But we certainly over the last 200 years see fairly intense exploitation of various groups. And it follows kind of a typical exploitation pattern, you know, thinking about the economics of it. We first target high value and fairly easy to exploit things. So Connor explained to us about fur seals and then southern elephant seals. We see some exploitation of seabirds, actually, penguins mainly, which I won't speak about. Then moving on to a more technologically difficult fishery, industrial whaling, before various finfish, and finally the current situation with krill, which is actually a very difficult fishery, technically speaking. So exploitation of these little guys and Arctic fur seals, that's the first one. So South Georgia is really important in this context because it hosts around 95% of the global population of Antarctic fur seals. So it's really the epicenter for this species around the world. I've taken an older figure here actually to show in purple the demographic history of Antarctic fur seals, so reconstructed from genetic data by people, including people in the room. And we can see sort of this strong dip, as Connor showed, followed by an increase. And then later we'll get to Jaume's paper, which shows the decrease again. But one of the really interesting, I guess, aspects of this, so over here we see exploitation of whales, is that, you know, there's this idea of the krill surplus hypothesis, essentially, which says that as we took out all these consumers over here, these whales, just a massive biomass of krill predators, that freed up a lot of krill for fur seals and other things to rebound. But it might not be that simple, actually. So Martin spoke about whales as ecosystem engineers. So one of the things whales do is actually to fertilize the Southern Ocean with micronutrients. So many areas of the Southern Ocean are actually nutrient limited, which means that even though, you know, there's enough light, etc., for phytoplankton to grow, they still lack things like iron in places. And whales do provide that through their feces. So there is also an idea that perhaps we didn't really see such a strong krill surplus hypothesis when whales were removed, because they actually weren't fertilizing the ecosystem anymore. But that's a much kind of larger discussion. So we saw this from Connor again. You know, we went from about 3.5 million Antarctic fur seals in 2009. Currently, we have, you know, this 7% decline that we're seeing. But I think it kind of clearly demonstrates that we're, and I'll come to this again and again through the talk, that we're now back in a situation where we have very strong bottom-up control of the system through physical oceanographic effects, which act on krill populations, and then finally on top predators. So in this case, Jaume and colleagues kind of show quite a complicated interaction with environmental things like the southern annular mode and the sea surface temperature, both of which act on krill populations, especially the size, frequency distribution of krill, which impacts fur seals. And then moving on to whales, as Jen nicely explained this morning, you know, we had this massive industrial whaling in the Southern Ocean, which removed in total probably about, well, more than 2 million whales actually from the Southern Ocean ecosystem. And again, as we saw in the beginning, we have this sequential exploitation of different species. So starting off with blue whales, very big, very valuable, moving to smaller and smaller species through to the late, well, to the 1980s, really, just before the moratorium in 86, 87, where people are actually catching tiny minke whales, you know, which are not very economically valuable at all. And the interesting thing there, I guess, is that we have sort of this opportunistic fishery, really, where this sequential exploitation, so exploiting less valuable species like humpback whales, fin whales, and so on, is probably what allowed blue whales to be hunted to such extremely low levels, so that whale fishery was actually supported by these species of less value, which allowed that extreme exploitation of, for example, blue whales. So it's something that we can see in natural ecosystems also through like co-exploitation or something called a predator pit basically. So it's an interesting aspect of the fishery for whales. And then finally, we have exploitation of various finfish species like the toothfish. So I apologize for the photograph. Turns out it's very difficult to find a good photograph of a Patagonian toothfish underwater. So this is a specimen from somewhere. It's a pretty scary photograph of what is actually an incredibly interesting and impressive animal. As we saw from Martin, the same paper led by Jose Abreu, I forget his first name. Yep. We can see that the fishery is very well regulated, in the latter decades. And the fishery in area 48, these purple bars over here, again, very well regulated at sort of just over 2,000 tons. There's much larger fisheries for Patagonian toothfish in other areas of the Southern Ocean. And then finally, we get to exploitation of krill. As I said, probably the most technically difficult fishery in the Southern Ocean, just because of the sort of level of investment it requires to do this. And also particularly for things like nutraceuticals, the difficulty of actually extracting that from krill in a sort of commercially relevant way, so to speak. So in the early 1990s, we see kind of a mini collapse of the krill fishery to do with the collapse of the Soviet Union, and actually subsidies for that fishery disappearing, especially from Eastern European countries. And then latterly, as Martin says, we've seen a real increase, a massive increase in the fishery in sub-area 48. So that's the Southwest Atlantic. It's essentially the only place people fish for krill at the moment. And that fishery is broken down into these things called sub-areas that Martin spoke about. For the whole area 48, we have this 620,000 ton trigger level, it's called. But that trigger level is also divided into a percentage catch per area that Martin mentioned. So the sub-area 48.1, which is the Antarctic Peninsula, the most intensely fished area, is right at that proportional trigger level at the moment, whereas South Georgia and South Orkneys are not very near it. But as Martin explained in 2024, this thing called Camelar Conservation Measure 51.07 or 5107, which set these proportional catch limits, so to speak, expired, and that no longer applies. The problem actually is that it's very difficult to know how much krill there is. So circumpolarly, Sally showed us that there's a lot of krill, but that's very difficult to establish with high certainty. And I think a nice, challenging example of that is the two most recent synoptic surveys for krill in Area 48. So these are massive, large-scale surveys over this whole Southwest Atlantic area using very similar methods, so they should be fairly comparable. And each different color line represents a different stratum, so a different area basically. And we can see that there are lots of changes in both the total biomass as well as the density of krill in areas. So just looking at this on face value, we might make some conclusions about, whether krill have increased or decreased and so on, but it's really not that simple. So if we go back to one of Sophie Fielding's figures, which we saw in Sally's talk before, this is the Western core box and krill density in different years. And we can see that it really fluctuates very widely from year to year. So that immediately tells you that it's very difficult to interpret a figure like this. We can't necessarily say that things have increased or decreased. And in fact, when we look at the sort of total biomass in area 48, it's probably similar from the 2000 survey to the 2018-2019 survey. So really introducing this new, essentially a brand new krill predator to the system, I think is what leads to system modification, or will lead to system modification. It has already. So we just see from one of Matt Savoca's papers, sort of the consumption of krill by blue, fin, and humpback whales per year. So it's quite a large number. But then we introduced this brand new krill predator, which is also, catching quite a lot of krill. So I think this is going to be one of the major sources of system modification. And not only do they, of course, also catch a lot of krill, but they do it in very similar areas to where predators go. Of course, they're targeting the same resource, so you would expect that. So this is one of Connor's PhD figures for South Georgia to make the talk a bit more relevant. And we can see the predicted distribution of fur seals on the left-hand side, and then the location of the fishery on the right-hand side. So you can see, as you would expect, that they are targeting very similar areas. But I think that's not necessarily a problem, and as I said, that's quite expected. But I think the problem is when we get to much smaller spatial scales. So as Martin said, there's nothing stopping the fishery at the moment from catching all of that catch essentially in a very tiny area. And we can really see that concentration in the Western Antarctic Peninsula. So these are tracking data from humpback whales, minke whales in the middle, and then vessel tracking, so krill fishing vessels on the right-hand side. And if we do an analysis called first passage time on these data, this tells us essentially the characteristic spatial scale at which predators are operating, essentially. So it tells us about the size of the area that they kind of characteristically search for some resource, krill in this case. We can see that humpback whales operate at a scale of about 20 plus or minus 20 kilometers. Minke whales, slightly smaller areas, 16 plus or minus 25. And then fishing vessels, a little bit bigger. But essentially, we're talking about scales of tens of kilometers, at which these things are searching for krill and exploiting that resource. So it's problematic that our management occurs at scales of, hundreds of kilometers, essentially, when the real interaction is happening on the scale of tens of kilometers. So we're trying to understand that, especially for fin whales. So that's me in the front of the boat this season around Elephant Island. And while Sally et al. Were having a good old time on SDA, big old SDA, we were getting out, can I swear here? We were having a challenging time around Elephant Island. The weather was very bad, so this is one of the few times we could actually get out on the boats and work on tagging fin whales and getting samples, which, as Jen said earlier, is very challenging. But hopefully these kinds of data will start to help us to address this issue of interaction between fishing and these mega consumers. So the interesting thing about fin whales especially is that they are obviously very big, nearly as big as a blue whale. So they eat a lot and they're very numerous. We saw that estimate from Martin Bu's work, but we know very little about them. So it's sort of the biggest unknown consumer, I would say, of krill at the moment. And then just as a sort of added extra, these tracking data are very valuable, I think, broadly speaking. So I just wanted to highlight some of the work we've done with WWF. It's a new website called bluecorridors.org, where we actually provide a tool to visualize these whale tracking data for stakeholders. So I think it's going to be a valuable resource for anyone who wants to understand any kind of management implications for whales, especially whales and dolphins. So then moving on to the sort of heart of the talk, I guess, climate change. I'm not an expert at all. I'm not a climate modeler or anything like that. So I'll give you a very few superficial points about this. And again, I would encourage you to look at some of the MISO documentation, for example. So a really nice infographic of the kinds of drivers and ecosystem implications of climate change in the Southern Ocean. And I guess the point here is that they are various, so we often think of the things I'll show in the next slide, but there are perhaps quite subtle changes which will have very serious implications for ecosystems. Well, this one's a little bit trickier to explain. So let me go to the very simple version from the IPCC report. So as I said, we tend to think of two things really. We tend to think of sea surface temperature. So we see generally mostly an increase in sea surface temperature, but it's not uniform. And we also think of sea ice. And again, we tend to think of diminishing sea ice, but around the Antarctic continent, probably until recently, it hasn't been uniform. It's actually been quite a complicated pattern, but the consensus is definitely now that we will see markedly lower sea ice, and we already are seeing that, as we saw in some of the satellite data from Sally's talk. So one of the very obvious manifestations of that or impacts of that is distribution shifts of organisms. So the idea really is that animals track the climate essentially, so they have a few options. They can track the climate, as I'm going to talk about now. They can adapt to different conditions and remain where they are, or they can go extinct, which is not a choice. So this, I guess by now, is quite a famous set of figures. So this shows krill distribution from a data set of krill surveys, net catches called KrillBase. And this is from Angus et al.'s 2019 paper, which there's a lot of debate around this, but probably shows distributional change and also abundance changes in Antarctic krill in the Southwest Atlantic. So the debate is really around variability, as I showed earlier, and also whether we can use this data set because it's not standardized to actually make this inference, which speaks to the problems of monitoring, I would say, that Martin mentioned earlier. But regardless, I think there is good evidence for some shifts in different trophic levels. And really one of the ways we can explore this for the future, so make projections, is using a tool called species distribution modeling. So we make an assumption with them and we say that we can explain the distribution of a given species based on the environment. Essentially, we say that we expect to see things shift to track the environment, as I said earlier. So we build models for what we see now, where animals are, and then we use Earth system models to look at how the climate changes, and we project the species distribution to the future. So lots of people have done that. This is one of Jen Freer here's papers for myctophids. And you'll see a lot of these, so I'll explain the sort of different variations of them for the next few slides. As I said, these are maps of where we think species will be, and in this case, it is a number of different models and whether they agree that species will kind of increase their probability of being there in the blue-green colors or decrease their probability of being there in the red colors. And the point I want to make, rather than any specific pattern for this one here, is that you'll see in most of these maps, the picture is quite complicated. So in general, the prediction is that species will kind of shift southwards as they try to track temperature, especially. But it's not a simple picture. It varies around the Southern Ocean, the specific pattern. And it also varies across different species, whether they are, for example, generalists, we find them in lots of places, or quite specific. the sort of magnitude of that change varies a lot. So this is an example for myxophids, as I said. A few years ago, we did a paper on which there were a lot of people from BAS, obviously, who contributed tracking data for, what was it, for 17 marine predator species. We put that all together in these models of where we thought the most important areas for marine predators in the Southern Ocean are. And very happily, South Georgia, the Scotia Sea, comes out very strong. And then we looked at the future and we essentially said, on this side, these colors over here are areas of ecological significance, which we think will be lost. So in orange colors, or we think will become new areas of ecological significance. And it follows a pattern that you'll see in lots of these things. We tend to lose habitat at the kind of northern margins of the distribution. So up there, for example, we kind of keep habitat in the middle, and then we gain some habitat in the southern margins as these things are shifting southwards. And so this is new stuff. So there's no time series bingo here. This is not even hot off the press. It's still in review. Out of Durham, so led by James Grecian. So we've built these species distribution models now for 28 micronecton species, and then we summarize them together. Finally, some squid, Paul, you'll be happy to see maybe. We haven't spoken about squid yet. So again, it's quite complicated. So these are the predictions for each of these groups where we think are important. And then we look at the end of century under two different scenarios. So 4.5 and 8.5. So those are different storylines for how climate, or at least how our actions might affect climate. So 8.5 is sort of considered the most extreme storyline. And we looked at whether we're going to see decreases in species distribution in a given area or increases in the blue. And again, we can see that the patterns are variable across different trophic groups. So again, we see sort of a southward shift of most things. For krill, we see really strong decreases kind of in the Scotia arc, which is concerning. Well, I say see, this is in predictions. So we predict or forecast them. But then interestingly, we see for squid, we see really strong increases actually, or very little change, which highlights one of the very interesting aspects and perhaps concerning aspects of these species distribution shifts varying across different species, and that we might see essentially changes in the kind of community we find at place. So in the Arctic, for example, you'll hear people speak about borealization, as more subarctic species are moving north. And I think there's a potential that that might happen to some extent in the Southern Ocean. For example, we might see some squidification of a lot of these systems as climate shifts. The one, I guess, really complicated thing is fronts in the Southern Ocean, which often form a barrier to many species. And it's quite uncertain what fronts will do in the future. So a lot of people actually think that positions of the fronts won't really change very strongly. And if that's true, then we might not see this, for example, squidification. And then we've looked at that in, for example, whales. So this is again, not even hot off the press. This is in review by Lena Ricola, who visited BAS late last year, I think it was. So she has a very nice tracking data set for southern right whales from all around the Southern Ocean. And essentially, again, for different populations, we really see a strong decrease in habitat suitability for lots of areas, probably a southward shift for southern right whales. And then I'm doing some work on humpback whales. using also tracking data from around the Southern Ocean. So these graphs show month by month the habitat suitability for the present and then the future. And the first thing we can see is obviously how the whales shift through the year, as they migrate southwards. But if we look at the colored lines, we generally see that they're often below the black line in places, which means habitat becomes less suitable. But we can overall see that they're different also in terms of timing. So we might actually see phenological shifts in when these whales are going to certain places. And then very near the end, we can project that forward. I say we, I wasn't involved in this work by Viv Talloch at all. And so each line, the black lines are assuming no climate change, and then the red lines and blue lines include krill projections or not. And basically we can see that mostly the colored or dashed lines are below the black line, which means that climate change is projected to really limit the recovery of lots of these whale populations. And we've heard a lot about humpback whales sort of recovering. So I think that, well, I and colleagues think that is probably over now. So in the Western Antarctic Peninsula, for example, in the last few years, we've really seen limitation in demographic parameters of humpback whales. So these colored lines over here are krill abundance in orange and sea ice parameters in blue. And then we have the pregnancy rates for whales. And we can see that the environment is now limiting the fecundity of these animals, essentially. So I think we're kind of, again, at a bottom-up limitation of that system. So to tie all this together, I think the management challenge really is managing in the face of uncertainty. I've shown you a few figures about how things change year to year. I've shown you figures about how we project things might change over decades. And that really presents a strong management challenge. So one of the things it will do is to change who manages areas actually. I'll come back to this one in a moment, Levi. Don't worry about that for the moment. But basically, as we see southward shifts, Camelar, which Martin spoke about a lot, will become increasingly important as a lot of these species kind of move into Camelar's jurisdiction. And then in terms of uncertainty or system modification, this is from 2003-7 review by Eugene Murphy, on which lots of you are co-authors. We've actually added new consumers at various levels over here. So we already have these food web interactions, but we've added a completely new consumer into that. And then if we look at the right-hand figure from the same place, so these are just different processes happening at different spatial scales and different temporal scales. And the challenge is that management must deal with, things happening from tens of meters squared over, weeks, months, all the way up to very large, long processes. So I think what we need there, firstly, is resilience or adaptability of management, to be able to respond to short-term changes. And then that might be very technically difficult. One of the things we need for that is much better monitoring. So Martin, for example, mentioned the KEMP program, which is about monitoring predators, but he thinks it's inadequate at the moment. But that's one thing we can improve with modern technology, for example, like Ash and Connor showed. But then the second thing I think which can be done is to become probably more precautionary in our approach. Camelar, to its credit, is already fairly precautionary, but I think it can be even more so. But of course, a challenge of that are things like, for example, the consensus system, where we need everyone to agree on a course of action, which is probably unlikely to happen, or increasingly unlikely to happen in the future. So it's an interesting time to be a scientist from an intellectual perspective, but it's a very challenging time to be a marine manager. So on that happy note, thanks.